This is Josh again, and this video is going to show you how to take a scanned Sherd and manipulate it using the Artec Studio software. What this will show you how to do will be to orient the Sherd, to stance the Sherd, to orient the Sherd the way you want it to look for publication and or for making a profile. It will show you how to create an abstract version of the Sherd, which is easier to work with and manipulate. It will show you how to export the Sherd into any type of 3D image file that you would like, and maybe a few other things that I'm not thinking of at this very moment. So what we see on the screen here in front of us right now is a Sherd that has just been scanned. So let's zoom in on it here. It's kind of a dark brown bowl, you can kind of tell already. This is from the archaeological site of Chhatarhuyuk. This is a Hittite Sherd. And so what we want to do first is come over here. We want to come over here to the tools window, and we want to do global registration, which is right here. What global registration does is it allows us to use many of the tools, most importantly these fusion tools. So go ahead and hit global registration, and then down here at the bottom you'll see this green bar go across 4 times. Now this is going fairly quickly because this piece that I'm working with has already been registered, globally registered. So for your pottery, it won't go quite as quickly because it will need to do it for the very first time. While we're looking at this, let me show you this grid in the background. These squares are 1 centimeter by 1 centimeter. This is asking me if I want to store deleted scans and undo history. Normally I say no, I do not want to store deleted scans. This is not something you're going to get when you first scan a Sherd. The reason this is coming up is I had a fast fusion model of the Sherd over here, and then I deleted it so that I can make a brand new one. Normally when you are asked this question, you want to hit no. You do not want to store deleted scans because it takes up a lot of space, it slows down the computer's processing ability, and if you've already deleted the scans, that probably means you don't want them anyway. Okay, so now this Sherd, this bowl rim, is globally registered. This now allows us to do fusion. For the archaeologist, I think it makes the most sense to do fast fusion. Fast fusion is just what it is. This is the quickest way to create a schematic abstracted version of this Sherd, which will then allow us to fix it if we need to fix it, and manipulate it more easily. So you just hit apply, and again, down here this green line will go across. And what we see is that I didn't scan this side of the Sherd. For some reason the scanner did not pick up the tweezers that I was using to hold it here, but it did pick them up here. So this is a really convenient Sherd to show you how to fix this, how to make this look like an actual Sherd. Also, I'll show you how to take a profile of it. So the first thing I usually like to do is I like to make the Sherd look whole. And what that is going to require is getting rid of this tweezer that you see here. Now there's a couple ways to do this. By the way, to zoom in gradually or out gradually, I'm holding down the right mouse button. And then when I move the mouse down, I zoom in, and when I move the mouse up, I zoom out. If I hold down the wheel button, I can move the whole thing around like this. And if I hold down the left mouse button, I can change my angle like this. So I want to erase this remnant of a tweezer, and so my preferred way of doing it is to kind of get a view that is flush with the surface that the tweezer is touching, and come over here to editor over here and select eraser. Now there's a 2-dimensional eraser and a 3-dimensional eraser. I never work with rectangular section selection or cutoff plane selection. The 2-dimensional eraser, both the 2D and the 3D selection erasers work by holding down the control button, which allows you to see the size of the eraser. If you use the scroll button, if you push the scroll button up, the eraser selection gets bigger, and if you pull the scroll button down on the mouse, the selection area grows smaller. So the 2-dimensional selection selects things at an infinite depth. So if I click here, this will be erased, and this will be erased, and anything that might have been behind the Sherd forever will be erased. So it selects a 2-dimensional space and erases everything behind that two-dimensional space. Obviously, we don't want to do that because that's a good piece of the sherd. The three-dimensional selection, which actually might be a slightly better choice for this example. The same thing works. If you hold down the control button, you can see how large it basically creates a ball, and only the space that the ball touches will be erased. So if I do the same thing here, this again will be erased, but there's nothing on this side. Only the depth of the ball is what gets erased. So let me try using the 3D selection first, and then I'll erase it, and I'll try using the 2D. So since I want the ball to be kind of small, maybe in that area, and I'm just going to highlight this stuff that sits on top of the body of the sherd. And what I'm doing is I'm holding down Control and I'm holding down the left mouse button to do this. And you'll see it's actually doing a really nice job of not touching the sherd and selecting only that part of the tweezer that I don't want. Take care of this too. Once you've selected what you want, I got a little bit of the sherd there, but that's not going to be a problem. Once you've selected what you want, maybe we'll get a little bit of this. Oh, that got too much, but that's okay. You hit erase over here, and of course it disappears. And now we've got this kind of gaping hole here, but that's not really too big of a problem. Because the next thing, if we feel that we've erased everything we want to erase, the next thing we're going to do to take care of these gaping holes is to come over here to Tools, and we're going to go to hole filling, which is the second choice in the post-processing selection. Now, hole filling is actually very useful. This number here, this 3000 here, I'm not exactly sure what that is measuring, but the larger you make that number, the larger a hole it will fill. So if let's say we had the entire rim of this vessel. In theory, if this number was big enough, it would not view the rim of the vessel as an acceptable hole. It would actually fill it in. This number would have to be huge for that, but in theory that would happen. This, relatively speaking, is a small series of holes or small series of gaps. I think 3000 will take care of it. So you hit apply, and there, it fills all the gaps for you, and it does a really nice job. I think it's similar to the GIS processes where you look at nearest neighbor and you extrapolate values. I think this is doing something similar where it extrapolates the value of these areas nearby and tries its hardest to just smooth the whole area over. So you can see here an outline of the tweezer and even this little bump here, which really probably does not belong on the actual sherd. And if we really wanted to, we would probably take the three-dimensional scanner and we would erase that. But that's not really important. But that reminds me, speaking of the scanner, of the eraser, let me take a couple of quick steps back here and show you how I would get rid of this using the 2D eraser, because I promised I would do that. So here's the eraser again. I'm going to change it to 2 dimensions, and I'm going to hold down the control button. And here, once again, I'm just shooting straight across the body of the sherd, trying to capture only the tweezers. And this looks like it's pretty good. Okay, so unfortunately I didn't get quite straight across, but if I erase this and then go to Tools, go to Hole Filling, you can hardly even tell. You can tell a little bit there. But if you're trying to just to get a profile of this, or you're trying to get the width of the rim or the body, it doesn't really change anything. So in order to get the profile, we need to stance the sherd. The way that I like to stance sherds is I like to come up. Now you're not going to be able to see this because I think it's cut off from the screen, but you go up to the top bar, and there is the third item in the third drop-down menu, and it's called View. You click View, and you'll see this window, and then you click Home. Home gives you a viewpoint that is directly perpendicular to the center of the X, Y axis, and then of course here's the Z axis in blue. I like to do all of my work working with this plane, this XY plane, because we don't have a plane, a gridded plane stemming from the Z axis, so it's easiest to work from the XY axis. So you go to View, you go to Home, and then this is where you're going to start. And you take a look at your sherd and you say, well, how am I going to rotate this so that it looks, so that I can begin to actually stance it? Well, I usually start by trying to rotate the sherd so that it is bisected by this XY plane. Now to rotate the sherd, you go over to Editor, which is above Tools, and you select the Transformation tool. This gives you three different options. It gives you Translate, Rotate, and Scale. Translate simply moves the sherd around. It doesn't change its orientation. Rotate is what you want for this purpose. So for Rotate, I will grab this green circle and use it to drag the sherd around, translate it back to the middle, more or less. And luckily, we're already actually pretty close. Let's pretend that the sherd was, let's mess this sherd up a little bit more to make it a little bit harder to work with. So let's say that the sherd looked like this. We'll go back to home. So again, you can start with any direction you want, but you're just going to slowly work this sherd into alignment for such that it is bisected by the XY axis where you would like to take your profile. Ideally, this will be where the sherd extends the furthest down here, so you can get the most thorough, the fullest profile possible. You also want to be careful of any marks or indentations here, or scratches or cuts, because they may be picked up in the profile that we create, but I'll talk about that more in detail later. So you're going to sit here and you're going to slowly rotate the sherd until it looks like it might be roughly stanced. So here it looks like the left side is lower than the right side. So I'm going to use the red wheel to rotate it like that. And I think it's pretty close. So now, to actually determine if it's close to being stanced, what I do is I take the Translate tool and I bring it over here and I line it up. Actually, we might rotate it a little bit more. And I line it up with this X, or with the Z axis line. And you want to get nice and close, and you just want to try to look straight across. And you can do this by lining up the Z axis with the X axis over here. Lining these two lines up, it gives you a fairly rough estimate of what straight across would be. And already I can tell that this left side is slightly lower than the right side. So back to rotate. Rotate that left side up a teeny bit. Okay, so it's not letting me rotate it up as much as I want. So I come over here and I see that this is the number that's changing. The x-axis is what I'm changing. And it goes from 152 to 144. So I'm going to change this to maybe 150. Hit apply. That's pretty close. Okay. Now that I think it is roughly, it's not necessarily stanced right now, but it is oriented roughly such that it is up and down, if that makes any sense. But I need to wiggle it, of course, to make sure I've got the stance. I come back to Translate, and I grab this. So there's two ways to use the Translate tool. You can use this box right here, and the box allows you to move it around like so, in any direction you want. Or you can use these arrows, and the arrows will only move the sherd in the direction that the arrow points in. So red arrow takes it backwards, and blue arrow, of course, takes it out. Right now I'm going to use this green arrow, and maybe I'll use the red arrow to line this back up. And what the green arrow will do is, watching this blue line of the z-axis, I'll bring the sherd up, and I'm going to look to see where the blue line disappears. If the blue line disappears all at once, which it's not really doing, then that would be roughly equivalent to stancing the sherd on the table such that you cannot see any light from it. So this is actually fairly close. If you look at that blue line, it doesn't quite disappear all at once, but it almost does. So we need to wiggle this a little bit. I'm tempted to wiggle it backward a little bit. So you go to rotate, and you wiggle it back just a little bit, and then you might have to translate it again a little bit to get it. Well, no, probably not. Well, you're going to go to translate anyway, so you can raise it. So now I raise it again. There. The blue line disappears a lot more completely here. Still not perfect, though. Awfully close. So maybe I will rotate this. You can also just kind of, again, look across the sherd, look at the near side, look at the far side, and see if they line up to your eye. This is awfully close, but I'm going to rotate it forward just a little bit more. Of course, the better you know your pottery, the better you can kind of estimate how the sherd should be stanced anyway. Hopefully I'm not demonstrating my lack of knowledge here. So we raise it up, and actually maybe I've bent it a little bit too far, because it is disappearing. Oh, well, there it disappears fairly quickly, but I think maybe we actually want to bring it backwards a little bit. Maybe like about there. And then we raise it up. That's pretty good. Obviously, it could be better, but for the purposes of this video, you can also look across it here. If this space between the blue line and the top of the Sherd is uniform, it's probably awfully close to being stanced, but it's not. I see a little bit of a dip here. So I could sit here and play with this for a while, or trust that you will know how to do it. This is very close to being stanced, but it's not 100% there. But for the purposes of the video, we're going to move forward as though it were stanced, so you don't have to watch me do this for 10 minutes. It usually doesn't take as long as 10 minutes. So now I want to take a profile of my stanced Sherd. So I'm going to keep it on the translate tool. I'm going to take this box and I'm going to bisect the Sherd by all three axes. So I want it to be right about there. Go back to your home view. Now, by bisecting the Sherd by all three axes, I'm guaranteeing a direct look into the center of it. If that makes sense. The physics of this is actually a little bit beyond my ability to explain, or not necessarily physics, perhaps the geometry. But what I like to do is I like to line up the Sherd along the most extended part of it, so I can get the biggest profile I can. So let's say that's roughly here. I want the z-axis to go straight through the Sherd, because that's going to be, the z-axis is going to be the perspective through which we are viewing the profile. And then, of course, from this perspective, we want to make sure that the Sherd is bisected by the axis perpendicularly. So we rotate this a little bit. And what I mean by that is we want this red line to enter the Sherd at a 90-degree angle. And again, you're eyeballing this here, but I would say this is pretty close. Okay. So we've done those things. We're going to move the Sherd forward a little bit so it's bisected by the z-axis. And we're going to say that we're ready to take a profile. So what we're going to do is we're going to take a profile of this part of the Sherd that is cut by the XY axis. So we'll hit apply to save all of your changes of the Sherd's orientation. Now, in order to take a profile of the Sherd, we go over here to measures. You click on measures and you click the middle selection here, which is called sections. You identify what you want to take a section of. In this case, it's the fast fusion. We could take a section of the scan, which you see here. This is what it looked like originally when we started, but we don't want to do that. That is not going to look very good for us because it's got holes in it and what have you. So you select your fast fusion, you hit next. Now you decide, well, parallel to what plane do you want to take your selection? Well, we want to take it parallel to X and Y, which is the gridded plane that we're looking at. So you'll probably not have to change that. You'll just probably keep it there. Now, once you're at this stage, now simply is where you select where on the Sherd you want the plane to fall. And what you're going to do is you're going to click on the Sherd as close to the gridded plane as possible. So right there. So you want your slicing plane to be lined up perfectly with the gridded plane, and here it is. When you've done that, you basically have your Sherd profile. You hit create selection, then you hit apply, then go back to your home view, and there is your profile with your 1 centimeter scale behind it. So this then means that you will need to do some photoshopping. What I would recommend is bringing this image into Photoshop either by hitting print screen on your computer, or by going to view and going down here to save screenshot, and it'll ask you where to put it and what type of file you want it to be. Actually, no, it only allows you to save it as a PNG, so you might have to do some conversion. Either way is going to work for you. Once you have it into Photoshop, you'll basically want to apply a scale that matches this 1 centimeter by 1 centimeter scale of the grid of the plane. And then you'll want to just take out this yellow line, which is the line of your profile. And you'll be done. Get rid of the grid, get rid of all these other colors, and you'll be ready to go. I hope that makes sense. Of course, those you folks in the field that will be doing this, feel free to email me and I'll be happy to try to answer any questions about it. I hope this video has been useful, and I am very happy to answer any questions, as I said.